number 2 as a little group, okay, which you may well be looking at or done, I don't know, but even if you've done it, it might be worth instructing to have a look at it. There's a few issues to come out of it, rearranging formulae, and also use of algebra to simplify it. So I'd quite like to have a look at this one. The first thing is to recognise that because it's a square section, B and D, we can call them both D, which helps. B is the same as D because it's a square section. And so if we're going to start working out the second moment of area I, then remember that equals BD cubed over 12. So in this particular case, for a square cross-section, which is worth remembering and might be worth actually adding to your list for the second moment of area formulae, because B and D are the same, it turns out to be just D to the 4 over 12 for a square cross-section. So that's worth pointing out to start off with. Okay. The second issue to come out of this is that if we're going to do this question, we need to know the dimensions, so we're after y effectively in that bending equation. If we write down the bending equation, which is stress over y equals m over I equals E over R, well, E over R is the one that's gone because we've got no idea what Young's modulus is and we're not interested in the radius of curvature. It's y that's going to allow us to find the dimensions of the cross-section area. So well done on that, okay? Because if we know y, going back to this diagram, remember this is the neutral axis here along the length of the beam. So the neutral axis is here. So we know that y equals d over 2. So once we've got y, we can find d and we know the dimensions of the beam. Okay? So the first thing to recognise is that actually, using the bending equation, we're after y. Which brings me to the next part, which is just rearranging that formula. And with these ratios, this is why I wanted to talk to all of you about it, because I should have made the point at the time. These ratios could just as easily be turned upside down and written the other way up. So, if I'm after the bottom part of the ratio, either y in this case or I, invert the ratios. So we've got instantly that y over sigma equals I over m. And now, to get y on its own, I just multiply both sides by sigma, and I've got that y equals I over m times sigma, and then I'm away. Okay? So that's worth remembering. If you're after the bottom part of the ratio, invert the ratios. Okay, I'll leave you to finish that off now.